Welcome back to the deep dive. It is Wednesday, February 25th, 2026. And, it is just hard to believe we're already nearly a quarter of the way through the year. I was actually looking at my calendar this morning, and it hit me that it's been basically 4 years exactly since the Big Bang, I guess you could call it, of AI coding
Oh,
tools.
yeah. The Big Bang is definitely the right phrase for it.
Right, like when GitHub Copilot, ChatGPT, Claude, when they all went from being those weird kind of clunky experimental toys to, the thing that writes half of my emails and a very decent chunk of my boilerplate code every single day.
It really has been a whirlwind. I mean, if you think back to 2022 or 2023, the conversation was so incredibly speculative. Everything was what if and maybe. But now, here in 2026, it's just the plumbing. It's the background radiation of the entire software industry.
Yeah, that's exactly the thing, though. Because it's the plumbing now, the conversation has sort of settled into these two really boring, highly predictable camps. On one side, you have the utopia crowd, and let's be honest, that's mostly VCs and CEOs, right? And they're just screaming from the rooftops that everyone is a 10x developer now, and we're just printing software for absolutely free.
Yes, the infinite productivity narrative.
Exactly. And then on the flip side, you have the dystopia folks who are basically saying the whole engineering profession is dead, pack up your desk, go learn to farm, it's all over.
It's a classic binary trap. I think it's comforting for people because it's simple, right? Either we are all tech gods now or we're entirely obsolete. There's no middle ground in those narratives.
But I've been reading through this State of the Industry report you brought in today, which is our main source for this deep dive, and it analyzes the actual landscape of code right now in 2026. And the reality it looks a lot messier. It's not a utopia. It's not a dystopia. Honestly, reading this, it feels a bit more like a slow motion industrial accident that nobody really wants to talk about.
That is a very sharp way to put it.
I just
Slow motion accident. Because the data in the report suggests we aren't seeing a mass replacement of developers like the dystopians warned about, but we are seeing a fundamental and frankly a deeply uncomfortable shift in what it actually means to be a developer.
So what's our mission today then? How do we unpack this for everyone listening?
The mission for this deep dive is to look at the bill that is finally coming due. Look, we've all enjoyed the incredible speed of these tools, sure, but we need to use this report to uncover the hidden costs to code quality, to security, and really to the long-term viability of software engineering as a human career.
Let's get right into it then. I want to start at the bottom of the ladder. Let's talk about junior developers. Because I look at what they have access to right now, and I'm not going to lie, part of me is a little jealous. When I was learning to code, if I hit a really weird syntax error, I was spending 3 hours digging through Stack Overflow threads from 2014. Now, a junior just pastes the error into their IDE chat window, and boom, it's fixed in 3 seconds. I mean, that has to be a net positive for breaking down barriers to entry, right?
Oh, in terms of sheer access,
Yeah.
absolutely. The barrier to getting a Hello World app running is basically zero today. You can get a full stack app spinning in a browser without understanding how a web server even works.
Yeah.
But the report highlights a massive looming downside to this. They're calling it the learning crisis.
The learning crisis, which on the surface sounds totally counterintuitive, right? Like they have access to the world's smartest, most patient tutors right inside their editor. How does that create a crisis?
Because the tutor is doing all the heavy lifting. Think about how you actually learned to code. Or really, think about how you learned anything difficult in your life. The learning didn't happen in the split second you got the answer right. The learning happened during those 3 hours you just mentioned.
The sweating and crying at the keyboard.
Exactly. The sweating, the reading through dry documentation, the tracing of execution paths in your head, just trying to figure out exactly why the code was failing. That struggle, it isn't an inefficiency to be optimized away. That struggle is the actual mechanism of learning.
Wow. So by removing the friction from the process, we're accidentally removing the learning entirely.
We are bypassing the mental gym. That's what's happened.
Yeah.
We are seeing a whole new generation of juniors who can produce functional working code at a truly frightening speed.
Yeah.
But they don't have the underlying mental models of why it works. They are operating at this extremely high layer of abstraction, and their understanding is incredibly fragile.
The source material actually uses a term for this that I haven't heard in a really long time: cargo cult programming.
Yes, cargo culting is back, and it's back in a huge way. For those who might not know the term, cargo cult programming is when you paste in a block of code because it sort of looks like the right shape to solve your problem, but you have no idea about the actual mechanics of it.
Right, like, I don't know what this function does, but it makes the error go away, so I'm leaving it.
Exactly. Now, in the past, you'd copy a snippet from Stack Overflow, but you almost always had to tweak it manually to make it fit your specific code base, right?
Oh.
Which forced at least a little bit of comprehension. But now, the AI formats the solution perfectly for your exact variables and architecture. You just hit tab.
I've actually seen this in the wild. A buddy of mine manages a front-end team, and he was telling me about a junior who shipped a React component a few months ago. And it worked beautifully in the local demo. But under the hood, the use effect hook, which is the thing that manages side effects in React, had a dependency array that was completely, totally wrong. The AI had just hallucinated a variable in there.
Let me guess how this ends. It works perfectly for about a week in production, and then it brought the whole browser down.
Spot on. 3 months later, under heavy user load, it triggered this massive, infinite re-render loop. But the worst part wasn't the bug. The worst part was that when they pulled the junior in to fix it, he literally looked at the code that he supposedly wrote and just said, I have no idea what this does.
And there it is.
Yeah.
That is the nightmare scenario the report is warning about. You have these enterprise code bases growing exponentially in size, filled with complex logic that the listed human authors do not intellectually own, which leads directly into what the report calls the interview paradox.
Oh man, this part of the report actually made me laugh, but in a really dark way. Because companies are still doing the exact same hiring rituals, right? They're still giving candidates those brutal, old-school leak code algorithm tests, like invert this binary tree on a whiteboard.
Which, ironically, is a task the AI can solve flawlessly in about 4 milliseconds.
Right. So the juniors are using AI tools to prep for and pass the interview, but then they actually get the job, and the day-to-day work requires skills that the interview didn't test for at all.
Completely. The job now requires skills like verifying AI output, deep architectural debugging, and prompt engineering strategies.
Yeah.
But we aren't testing for that. It's a massive systemic mismatch. We're using 2020 filters for a 2026 reality.
Hmm.
We are hiring people because they are very good at cheating on an outdated test, not because they are good at the modern job.
And the real tragedy of it is that the juniors are the ones suffering the most because they get in and they aren't getting the human mentorship they actually need. The senior devs are all just assuming the AI is acting as their mentor.
Yeah, it's a very lonely time to be an entry-level developer despite all the tools.
Let's move up the chain a bit to the mid-level developers. These are the folks with, say, 3 to 5 years of experience. They know their way around a loop. They understand the architecture. Surely for this group, this tool is just an absolute rocket booster. I mean, I use it for writing simple CRU'd apps, create, read, update, delete interfaces, and it literally saves me hours of typing.
And for that boilerplate, for the highly repetitive, boring stuff, yes, it is fantastic. The report fully acknowledges that. If you need to scaffold a standard test suite or write a basic API endpoint, AI is the ultimate force multiplier. It's the best rubber duck you could ask for. But the danger for mid-level devs is a lot more subtle. The report refers to it as the illusion of velocity.
The illusion of velocity. So that implies we think we're moving incredibly fast, but we're actually just kind of spinning our wheels.
We are moving fast, but you have to ask, in which direction? Because the industry metric has silently shifted to lines of code shipped per week. But more code does not equal better software. In fact, usually it's the exact opposite. Every senior engineer knows the bottleneck in software was never how fast your fingers could hit the keys.
Right, the bottleneck was always.
Yeah.
Do we actually understand the business requirements? Is this the correct architecture for this specific problem? Is the system we're building going to be maintainable in 2 years?
Precisely. And the AI actively encourages you to skip that deep thinking phase because the typing phase is suddenly so frictionless. And there's a very specific trap here that mid-levels fall into, which the report calls pattern matching.
How does that work in practice?
Well, you have to remember what large language models actually are. They are prediction engines. They are trained on the statistical average of all the public code on the internet. So they are incredibly, almost magically good at solving common problems in very common ways.
Ah, I see. They're like the ultimate cover band. They can play all the greatest hits perfectly.
That's a great analogy. They play the hits. But they absolutely cannot improvise. So the moment a mid-level developer hits a domain-specific problem, something truly unique to their company's weird, bespoke business logic, the AI will confidently suggest the standard internet solution. And because the developer has spent the last 2 years learning to trust the tool, they just implement it.
But the standard solution might rely on a database schema they don't actually have, or a security model that completely violates their internal company policies.
Exactly. And here's the kicker. It fails silently. It doesn't throw a syntax error. It doesn't crash the compiler. It creates a very subtle logical flaw that might not be caught for 6 months. So you end up with mid-level developers shipping 3 times the volume of code, but the density of bugs and the amount of technical debt is scaling right along with it.
Technical debt delivered at Mach speed, which naturally brings us to the poor souls who actually have to clean all this mess up, the seniors and the staff engineers. Reading this report, I get the distinct sense they are not having a great time in 2026.
They are exhausted. The job description for a senior engineer has completely flipped on its head. They used to spend their time designing elegant architectures and building the most complex features. Now, they are essentially full-time professional code reviewers and forensic investigators.
Just because they have to constantly review this massive, never-ending flood of AI-generated code coming from the juniors and the mid-levels.
Yes, and we really need to consider the cognitive load of doing that kind of review. This is a critical insight from the report. Think about it. If I hand you a piece of code that a human wrote, and it's obviously broken, say, it has syntax errors, or it's missing a bracket, or a variable is undefined, your brain spots it almost instantly. It's an easy fix.
Yeah, it's like reading a newspaper and seeing a massive typo in the headline. Your brain just flags it immediately.
But AI code is almost never obviously broken. It is, by definition, plausible. It compiles perfectly, looks totally idiomatic. It even uses the right naming conventions for your project. To find the bug in AI code, you can't just skim it. You have to read every single line with intense focus, simulating the entire logic flow in your head.
Wait, so you're saying reviewing AI-generated code is actually cognitively harder than just writing the code yourself from scratch?
Significantly harder. You're constantly fighting your own brain's urge to just stamp "looks good to me" on the whole request because the code looks so visually correct. But buried deep inside that flawless syntax is a subtle off-by-one error or a nasty security vulnerability. The seniors are becoming these massive bottlenecks because they can't trust anything they read, but they physically cannot keep up with the volume of code being submitted.
You mentioned security vulnerabilities, and I want to double-click on that because I feel like the mainstream narrative is often, well, AI is smarter than us and it writes better code, so it must be safer. But the report suggests the exact opposite. It cites a couple of major studies, I think from Stanford and GitGuardian, showing a real spike in vulnerabilities. Why is that? Is the AI doing this maliciously?
No, it's not malicious at all. It's just entirely indifferent. And we have to stay grounded in how these models actually function under the hood. They are probabilistic. They predict the next token, the next piece of a word, based on statistical likelihood. They are not querying a verified database of safe enterprise coding practices. They are querying the mathematical average of the entire internet.
And the internet, as we all know, is completely full of terrible, insecure code.
Exactly. The internet is stuffed with quick and dirty tutorials from 2018 using deprecated, broken libraries. It's full of hard-coded API keys from students' public repos. The AI sees all of that and goes, well, statistically speaking, this is how human beings write this kind of code, and it dutifully replicates it.
Can you give us a concrete example of what that looks like in practice for the listeners who might not be deep into security?
Sure. A really common one involves insecure defaults. Say you ask an AI to spin up a quick Python web server using Flask. The AI might very confidently suggest a configuration that sets the flag debug equals true. Now, that's great if you're testing on your laptop, but it is catastrophic if that exact line of code slips into a production environment because it exposes your internal system to anyone on the web. Or, for instance, it might suggest an older encryption library that has known severe vulnerabilities simply because that older library appears millions of times more often in the historical training data than the newer, safer one does.
That makes so much sense. It optimizes for it works, not it works safely.
It optimizes for it looks exactly like the training data. And since the training data is inherently historical, the AI constantly drags the past and all of the past's mistakes right into the present. It creates this bizarre homogenization, this monoculture of code where novel, creative, and secure solutions become much rarer.
There's another technical limitation the report gets into that I feel like the tech press totally glosses over. Context windows. We constantly hear these tech keynotes bragging about massive context windows. 1 million tokens, 2 million tokens. Doesn't that huge memory solve the problem of the AI not understanding the whole system?
It definitely helps, but it's still fundamentally a keyhole view. Even with a 2 million token context window, And AI cannot effectively hold the entire nuanced architectural context of a massive enterprise system in its working memory. It sees the specific file you're working on, it sees the related modules you pasted in, but it doesn't truly understand that a tiny schema change in the user database module is going to crash the analytics pipeline that lives 3 microservices away.
Ah, it lacks the theory of mind for the software architecture.
Exactly. Humans, especially seniors, build robust mental maps of abstract systems. AI builds statistical maps of text. And those are two very, very different things when the servers are on fire at 3 a.m.
That's a sobering thought. I want to pivot a bit to something that affects everyone listening to this, even if you don't work in a massive corporate office, and that's the open source ecosystem. All of these incredible tools we're talking about, Copilot, Claude, ChatGPT, they were originally trained on open source code, but the report paints a genuinely grim picture of what's currently happening to the actual human maintainers of that open source code.
This is, in my professional opinion, the most unethical and dangerous part of the entire 2026 landscape. What we are witnessing right now is a tragedy of the commons on a global digital scale.
The report talks about a flood of pull requests. Can you break down what's actually happening on the ground for these maintainers?
Okay, imagine you are a developer who maintains a popular open source library. You do this entirely in your free time, on weekends, because you love the community. Suddenly, over the last 2 years, you start getting dozens, maybe hundreds, of pull requests, code contributions every single week. And they're all clearly AI generated. Some of them are just fixing random typos. Some are adding completely useless bloated features. And some are subtly, dangerously broken.
But as the maintainer, you still have to review all of them, right?
You have to. That's the burden of being the maintainer.
Mm.
But now, instead of reviewing thoughtful, high-quality code from other passionate human beings, you're essentially sifting through low-quality AI spam that looks just plausible enough to require a deep read. It is a massive unpaid labor tax. And because of it, these core maintainers are burning out and quitting. They didn't sign up to be unpaid janitors for robot code.
And the really dark irony here is that the massive tech companies making billions of dollars off these AI subscriptions are the exact same ones causing the problem. They scraped all that open source code for free, they trained their models on it, they sold those models back to developers, and now those developers are using the tools to inadvertently spam the original creators.
It is pure extraction without reciprocity. It's strip mining the community. And here's the existential threat. If the open source maintainers finally throw their hands up and quit, the entire foundation of the modern internet crumbles. Because who writes the security patches next year? Who architects the new paradigms? The AI cannot invent the future. It can only regurgitate the past.
That directly connects to another concept in the source material that honestly sounded like the plot of a sci-fi horror movie, the documentation death spiral.
Oh, it's not sci-fi. It's happening right now.
Yep.
Look at developer behavior today. Developers are reading official documentation way less than they used to because it's so much easier to just ask the chatbot, hey, how do I authenticate with this API? And the bot just spits out the answer.
Right. Which means traffic to the actual documentation websites drops off a cliff.
Traffic drops, page views plummet, and so companies look at those metrics and say, well, nobody reads the docs anymore. Let's stop paying technical writers to update them. But here is the massive catch that everyone is missing. The AI learns how to answer your questions by reading that documentation. If humans stop writing and maintaining high-quality docs and tutorials, the training data for the next generation of AI models dries up.
Wow. We're literally cutting off the food supply for the models we rely on.
We are, and we're seeing this canary in the coal mine with Stack Overflow right now. Traffic there has absolutely cratered. And it's not just the answers we're losing. The human conversation, the messy human debate in the comments about why a specific answer is right or wrong for a given edge case that context is disappearing, we are basically burning the library to keep the house warm for one more winter.
That is such a vivid, terrifying image. Burning the library. Let's pull the lens all the way back and look long term. If we play this current dynamic out for another 5, maybe 10 years, the report mentions a severe pipeline problem for industry talent.
Yes, and this is the piece that genuinely keeps me up at night. You have all these tech companies looking at the immediate efficiency gains of AI and saying, great, our mid-levels are 3x faster, so we just don't need to hire as many junior developers anymore. And on a quarterly spreadsheet, that makes perfect financial sense. But a senior engineer is just a junior engineer who survived 10 years of making horrible mistakes.
So if you stop hiring juniors today, you completely stop manufacturing seniors for tomorrow.
Exactly. Fast forward to 2036. Who is going to lead the complex engineering teams? Who is going to have the deep, hard-won intuition to debug the legacy distributed systems? We are creating a massive generation gap in our own profession. We might get a golden decade of incredible efficiency, followed immediately by a catastrophic crisis of competence where nobody actually knows how the underlying machine works.
This actually leads perfectly into the concept of deskilling. The report uses an analogy here that I found super helpful comparing software developers to airline pilots.
It is the perfect analogy for what we're going through. We know from decades of aviation history that when pilots begin to rely too heavily on autopilot systems, their manual stick and rudder flying skills begin to atrophy. And when the autopilot inevitably encounters a storm it can't handle and disengages, the human pilot suddenly struggles to take over because they've completely lost the feel of the plane.
And in coding, taking over manual control means debugging a critical production outage at midnight when the AI agent is completely confused.
Precisely. If you spend the next 5 years letting an AI write all of your complex SQL queries, and then suddenly the main database goes down,
Yeah.
and you need to write a highly complex multi-table join manually just to save the user data, can you still do it? Or are you going to be totally paralyzed because your chatbot API happens to be down too?
Which brings up vendor lock-in. We are weaving these proprietary closed box APIs so deeply into our daily workflows.
We are building our entire professional lives on rented land. We don't control these models. We don't control the subscription pricing. If OpenAI or Anthropic or Microsoft decides to change their model weights tomorrow, or they deprecate a feature you rely on, your entire personal workflow just breaks. We are eagerly trading our autonomy for short-term convenience.
And not to mention the environmental cost. The report briefly touches on the carbon footprint of all this. The sheer scale of compute required so that millions of developers can have autocomplete generate 10 lines of code every 5 seconds. It's staggering.
It is an incredible amount of energy being burned, often just to generate code that gets deleted 3 seconds later.
Look, we've covered a lot of really heavy stuff today. The learning crisis, the illusion of speed, the burnout of open source maintainers, the de-skilling of the workforce. It feels pretty bleak. But I want to make sure we're being completely fair to the technology because I use these tools every single day, and frankly, I don't think I could ever go back to coding in a plain text editor without them. So is the ultimate verdict of this report that we should all just unplug the tools and go back to 2019?
No, not at all. And I really want to be very clear about that for everyone listening. Telling developers to stop using AI would be like smashing the printing press because you're annoyed by typos. The tools are genuinely, fundamentally useful for learning new syntax, for translating logic between different languages, for eliminating the mind-numbing drudgery of boilerplate,
And the ring
absolute miracles of technology.
There's a big but coming.
But we have to fundamentally stop treating them as intelligence. They are not intelligent colleagues. They are incredibly sophisticated text predictors. The profound danger comes when we begin to substitute their statistical output for our own human understanding. The danger is when management starts using lines of code generated as a legitimate productivity metric. The danger is when we assume a piece of code is secure simply because a multi-million-dollar computer wrote it.
So really, the core tension of our industry right now is between speed and correctness.
Speed is easy now. AI has completely solved the speed problem. Correctness, reliability, long-term maintainability, those are the hard problems. And they are still deeply human problems. And right now in 2026, the industry is essentially drunk on speed, completely ignoring the massive hangover that is inevitably coming tomorrow morning.
There is one final, incredibly provocative concept from the end of the report that I want to leave everyone listening with today. It's a little bit abstract, but I think it sums up this entire precarious moment perfectly. The concept is called model collapse.
This is the theoretical feeling that we might be hitting very, very soon. Think about it. As the internet continues to flood with AI-generated code, articles, and documentation, the future generations of AI models will inevitably be trained on that new content. They will literally be training on the synthetic output of other AIs.
Right, it's like making a photocopy of a photocopy.
Exactly. And if you keep doing that, eventually the image just becomes pure noise, the variance in the data disappears, the creative, weird human edge cases vanish. We risk ending up in this closed-loop digital echo chamber where we are just endlessly recycling the exact same average ideas forever, while the ability to create something truly novel, real human novelty, is just permanently lost in the statistical noise.
A photocopy of a photocopy of a photocopy. Wow.
Yep.
Well, on that wildly cheerful note, if you're listening to this right now, maybe check that pull request one more time before you hit merge. Read the code. Actually, really read the code.
Please, for all of our sakes, read the code.
That is going to do it for this deep dive into the state of software engineering in 2026. Thanks so much for joining us.
Thanks for having me. Keep coding, and more importantly, keep thinking.